Hello, I'm going to show you how to fill out the 3-1 notes today. It says, suppose an airline allows passengers to check a maximum of 50 pounds of luggage. What is the maximum allowable weight of a passenger's second bag if his or her first bag weighs 10 pounds? Well, if the first bag weighs 10 pounds and you're allowed up to 50 pounds, you simply need to compute the difference between 10 and 50. So 50 minus 10, you could bring 40 more pounds. And if it's X, it's going to be 50 minus X. There you go. It's an expression as your answer. Okay, today's lesson is called Arcs and Angles. If M is the measure of an angle, then the angle is a zero angle if and only if M, the measure of the angle, equals 0. It's acute if M is less than 90. It's right if M equals 90. It's obtuse if M is greater than 90. And it is straight if M equals 180. So this right here, this picture is the zero angle. This is the acute angle. This is the right angle. This is obtuse right here. Oops, and that happens. And this is the straight angle right here. Okay, and that's all your angles, all your different types of angles. Okay, all right. The first example says, draw a figure in which ABE is a straight angle, angle ABC is a right angle, and the measure of angle CBD plus the measure of angle DBE equals 90. So the first thing we need to draw here is angle ABE, which is to be a straight angle. So if it's straight angle, it's 180 degrees. It'll look like this. And it wants it to be labeled A, B, and E. It says angle ABC is a right angle, ABC. We'll put C up here, so that makes it right. And CBD plus DBE equals 90. So the new point here is D. Now notice that this starts with C and this contains an E. So that means that D must be over in this region right here. And let's just check and make sure that works. So CBD, plus DBE, that should equal 90. Yes, those two angles together would equal a 90-degree angle. Okay, so that's the correct picture right there. The next example says, in the figure below, the measure of angle CGE equals 75 degrees. What's the measure of angle EGF? So CGE is 75. The best thing you can do here is label the picture. And EGF, it wants to know what that is. So that would be this angle right here they're asking about. Well, the whole thing is 90, as indicated by this box. And so we're going to take 90 minus 75. That's going to give you 15. So 15 degrees is the answer. Okay? An arc is a fancy word for a thing that looks like this. And that thing right there, that's part of a circle. So write part of a circle. That's what an arc is. Now, within the category of arcs, we have some different names for different types of arcs. There's the minor arc, which is less than half a circle. There's the major arc, which is more than half a circle. And there's the semicircle, which is half a circle. All right, those are the special types of arcs. So a minor arc, oops, where'd my L go? There we go. A minor arc is named with two letters. And an example in this picture down here would be arc FE, right there, arc FE. And the way you write that is with an F and an E with a little arc symbol above the letters. That is read arc FE. Now, major arcs, you need actually 3 letters to name them. Because if you want to specify, for example, let me get a different color here. If you want to specify that you want to talk about this arc right here, you can't call this FE, because if you say FE, it's assumed that you are talking about the minor arc. So you have to actually use 3 letters when you name a major arc. So you could name this FGE, because it starts at F, passes through G, and goes and ends at E. So an example of a major arc is FGE. Right? And then there's the semicircle, which is also named with 3 letters. Okay, so we actually don't know for sure in this picture if this is actually half of a circle, but we're going to assume that this is 180 degrees from here to here. Let's just pretend that's 180. Okay. So if you wanted to name this semicircle right there, you'd have to put, well, if you wanted to name that one, you'd have to actually create another point and name it. Okay, so we actually can't name that particular semicircle without creating another point. But if we go the other way, let me use even a different color here. We'll go green. If we want to talk about this semicircle, we can call that arc GFE. Okay. And by the way, arc EF is the same as arc FE. Same thing. Arc EGF is the same as arc FGE, and arc EFG is the same as arc GFE. Okay. It means the same thing. The order of those letters isn't important. Now, a central angle is an angle. I'm going to use the angle symbol. This means angle. It's the angle in the center of a circle. Okay? That's called a central angle. And then we've got some central angles in this picture right here. It says find the measure of angle ROS. This literally could not be any easier. The measure of this angle, ROS, is equal to the measure of its arc right there, which is 32 degrees. So that's a 32-degree angle. And then it says find the measure of arc RTS. I'll use a different color. I like colors. RTS is this arc right there. It's that major arc. So, well, a whole circle is 360. So it's basically the whole circle except for that little green arc, the 32-degree arc. Well, so the whole circle would be 360. The little arc is 32. That means that red arc must be 328 degrees. Okay, and there's our 2 answers for that example. Now, the last part of this lesson is just about what in geometry are you allowed to assume, okay? In geometry, there's literally only 2 things you can assume, 2. And there's nothing else other than this, other than 2 things I'm going to write down. Okay, the first thing you're allowed to assume is that points drawn on a line are on the line. So if a point appears to be on a line, you're allowed to assume that that point is actually on the line. Okay? Now, the only other thing that you're allowed to assume from a drawing is this. Points between, oops, what? I don't know why that happens. I apologize. I don't know why that happens. Points between other points are actually between. Okay, they actually are. So if you see a point that appears to be between two other points, it actually is between those two other points. Okay, there's nothing else that you can assume from a drawing in geometry. Pictures are very deceiving in this subject. So in activity 2, we're going to look at what are we actually able to assume from the figure and what can't we. So number 1, it says T is on N. Well, T appears to be on line N. Are we allowed to assume that points drawn on a line are actually on the line? Yes, because of rule number 1, this is a yes, okay? You're allowed to assume that. It looks like angle JIK, that's this angle right here, it might be bigger than angle KIE, this angle here. But can we assume that from the 2 rules that I just went over? No, it says nothing about angles that appear to be a certain way actually are a certain way. That was not either of the rules. It kind of looks like line M is parallel to N. Is that one of the rules? No, it's not. It's not. We can't assume that. They certainly look like they're parallel, but we can't assume that. Angle JIT, that's this angle. I'll switch colors here. That's this angle right here, JIT. It certainly looks like it's 90, doesn't it? But we're not allowed to assume that it is. It's not marked as 90, and it's not one of the 2 rules that I just wrote down. T is between A and E. Well, there's point T, and it looks like it is between A and E. So is that one of the rules? Oh, yes, that's rule number 2. So that's a yes. That is allowed. It appears to be between the 2 other points. And according to rule number 2, that means we can actually say that it is between the 2 other points. It says A, I, and E are collinear. Collinear, remember, means that they are on a line together. So A, I, and E all appear to be on line N. Can we assume that they actually are on line N? Yes, we can. That's rule number 1. Points drawn on a line are actually on the line. And then the very last one says J, K, and L are collinear. Kind of looks like you could draw a line through those 3. But are they actually drawn on a line together so that we are allowed to assume it by rule number 1? No, they're not. They're not. I created that line, and we're not allowed to assume that they actually are on the line together. I hope you enjoyed the video, but if you didn't, that's okay too. Oh, you always see the ceiling at the end of these.